Hey everybody, for this video we're going to be doing logarithmic and exponential equations. This is sort of the whole point of this is what if we end up with logarithms or exponential equations, how do we solve them? So all the previous videos was all a build-up for this particular one. We're going to start where we have a log of a base of x is equal to a number of some sort, kind of like what we have here. We're going to convert it into its exponential form. So this becomes 2 to the 5th power equals 7x plus 5, and you can see that's what we have here. This takes practice. 2 to the 5th is 32. Subtract the 5, divide by 7, and we get to here. For this one, what we're going to do first is get rid of the 9 halves by multiplying by the reciprocal. You can see I have that in red here. And the idea is to get the logarithm by itself first and then convert it into exponential form. So this will become x equals 3 raised to the 8/9 power. You can see that we have that there. You should be able to write it in either form. Here it is in radical form as we're looking at that. Just a quick note that I made here. It has to be the log of a positive value. So when we go through this next one, and we're going to end up with a couple of answers, we're going to have to kind of keep an eye on that. So here's my next equation. I notice I'm adding here, and from the previous video, add means multiply. Then we convert it. Notice that there's no base written in here. That implies that this is log base 10, or the common log, as it's often referred to as. So this becomes, the domain here is equal to the base raised to the power. So there's 10 to the 2nd power, which is 100. Here I distributed. And I have a quadratic here now. I have to use the quadratic formula in this case. So I crank through that, and I end up here. Now we have the plus and the minus case. The minus case is a problem. When I do negative 5 minus 5 root 17 over 2, I get a negative value, and I can see right here, x has to be positive in this case. So the negative one we actually throw out, and we just keep the positive one. Here we're subtracting, and again, notice that this is base 10, it's log, and there's no base written in, so it's an implied 10. Subtraction means that we're dividing. So here we are dividing. This becomes the domain, the x plus 5 over x plus 2 equals the base 10 raised to the 2nd power. Then you just solve for x. For this one, once again we're adding, so it becomes multiply. And we end up with a quadratic again. Now when we convert it, again, it becomes the domain, which is here, equals 2 raised to the 4th power in this case, which is 16. I now have a quadratic that factors very nicely. Now I have to be careful. When I take x equals negative 2 into here, I'm taking the log of a negative value. So we actually cross it out. We don't include it. 8, however, when we plug it in, we end up with positive values, and we're good to go. So in this case, the only answer is 8. Our next case that we have here is we have a log of a base equal to a log of a base. Now the domains are different, but what in reality happens is they have to equal one another. So in this case, this is log base e, or the natural log. Notice I'm adding here, which implies multiplication. That means that the natural log of this has to equal the natural log of that, which means the insides must be equal to one another. Distribute and solve. Now we have to be careful again. When I plug in 0 to here, or here even, do you see I'm taking the natural log of negative 6? We can't take the natural log of negative 6. Even here, the natural log of 0 also is not going to be acceptable, here or here. So 0 gets thrown out. The answer is just 8. For this one, I'm adding, which becomes multiply again. And you'll notice it's the same base equals the same base, which means the domains must equal one another. Distribute, get all to one side and factor. We get 2 potential answers. Negative 3 or 2. By the way, even though we throw out some of the negative answers, just because the answer is negative doesn't mean that we throw it out automatically. You can see when x equals negative 3, that's not a problem here. So it's very possible that negative 3 could be a solution. We don't just throw it out because it's negative. Once we plug it in, if we take the logarithm of a negative value, which we are here because of the negative 3, then we have a problem. And I wrote it out here. 2, however, works out just fine for us. The third case is when we have Two bases that are equal implies that their exponents must be equal. So here I have 3 as a base, 9 as a base. However, the 9 I can easily turn into a 3 squared. Now the bases are the same, which means the exponents are the same. Solve a linear equation, and we're good. By the way, there are no restrictions for exponential equations, meaning if I get a negative in the exponent or a positive, it makes no difference. All the answers are fine. This one here, now this looks like the bases are different, but if I go e to the 0 power, which is 1, now I force them to be the same. So the exponent equals the exponent, solve for x. Now this next case is we have an exponential function, and we're going to assume that b and c can't be connected like we did up here where we could make them the same bases. So if we can't make them the same bases, then we're going to have to apply logarithms. So for this example, I can't turn the 6, like 32 is 2 to the 5th power, but that doesn't help me with the 6. If it was 36, then we'd have something, but it's not, it's 32. So I'm going to go ahead and take the log of both sides. In this case, I chose the common log, base 10 meaning. And what that does is that's going to take what's in the exponent and bring it down in front. Now it's multiply. Divide both sides by log of 6. Then we add 5 and divide by 5. And here's my decimal approximation. Let me show you how I put that in my calculator. So log of 32, close, divided by log of 6 equals plus 5 equals, then here it's divide by 5, divided by 5 equals. I would do it that carefully in that order. It's very easy to make a mistake with parentheses and things like that on problems like this. For number 11 here, the obvious choice is the natural log. And you can see the base E, remember they cancel out completely. And here I have natural log of 26. So all I have to do here is just divide by 4. Again, I would be extra careful. ln of 26, close, equals, divided by 4. And you can see I got this answer here. So notice that I broke it up into a couple of steps in the calculator. Sometimes putting everything all in at once can force mistakes. For number 12 here, this is the most complicated type that we could do. And you can see I'm going to take the log base 10, the common log, to both sides. Very nicely, these two bases are the same, so that goes away and becomes 1. However, here, it ends up, I'm going to have to take natural log of 7 and distribute it to the negative 7 and to the 2x, which is exactly what I did here. Notice it stays 2x minus 10 here. Next up, I have to get all the x terms to one side, so I'm going to subtract the 2x to this side, it gives me the minus 2x, and I'm going to add that to this side. So you can see the positive 7 log of 7, and then there's the minus 10. Greatest common factor here is an x. Actually, it's not the greatest common, 2x would be, but we want to get the x by itself, so I factor the x out, and I'm left with the 2x log 7 minus 2. Then you divide both sides by that. You'll have to study that one a few times. That one's going to take a little bit of time. Here we have an application of logarithms. Here's our equation. We have bacteria growing according to this population here. This is actually a very common growth formula, where t is the number of hours, and we're going to estimate when the population will exceed 788 colonies, most likely it does. So basically, when is the population at 788? So I take the p of t and replace it with the 788, and now I'm trying to dig t out. So I'm going to divide both sides by 350, take the natural log because I'm using base e here. That, of course, comes down and goes away. So the 0.14t is now over here. Log here, I just rewrote it. And to get t by itself, I'm going to divide both sides by 0.14. And let me show you in the calculator how I did this. So I did 788 divided by 350 equals, and I did the natural log of the previous answer. Previous answer is above the negative button there, so I hit the blue and then answer, so that's the previous answer. And then I divided the whole thing by 0.14. And you can see I got my 5.8 hours.